We're all familiar with the image of a black hole, that dark region of space where everything falls in and nothing escapes. But have you ever wondered if there exists a place that pulls everything in? Could there also be a place that spits everything out, never letting anything in? That's exactly what a white hole is, one of the strangest ideas ever proposed in physics. And here's the fascinating part. White holes aren't just a product of imagination, but a real solution found within Einstein's equations. When we think of the strangest places in the universe, we often imagine black holes, regions where everything, even light, is drawn in and can never escape. But few people know that the opposite of a black hole also exists, at least in theory, a completely contrasting entity where matter isn't pulled in, but rather pushed out. This is what we call a white hole. By nature, a white hole is a space-time structure that allows matter and energy to erupt outward, but blocks anything from entering. It's like a cosmic volcano, forever erupting, never swallowing, when time is reversed. The concept of a white hole doesn't come from science fiction, but from the logical extension of Einstein's field equations in general relativity. If we reverse the flow of time in a black hole model, a new entity emerges, not one that absorbs, but one that ejects. Physicists like Nathan Rosen and John Wheeler were among the first to explore this symmetry when deeply examining space-time structures. They realized that if a black hole represents matter falling forward in time, then a white hole is the reverse matter being returned from a singularity. To visualize it, if a planet is pulled into a black hole and torn apart, then in a white hole, matter bursts forth from apparent nothingness, no clear origin, yet still following the laws of physics in reversed time. Wormholes and interdimensional gateways. Let's take this further with an even bolder idea. Wormholes. These are theoretical tunnels connecting two distant points in space, or even two separate universes entirely. In this model, one end of the wormhole is a black hole pulling everything in, while the other end is a white hole expelling everything outward. If real wormholes could let us traverse millions of light years in a single moment, but that's an ideal on paper. In reality, wormhole models are severely unstable. Even a single photon entering could collapse the structure instantly. Since white holes are potentially one end of a wormhole, they inherit this fragility. In a universe filled with dust and radiation, white holes would struggle to survive long enough to be observed. Could the Big Bang be a massive white hole? An intriguing hypothesis proposed by cosmologists is this: if the Big Bang marked the birth of all matter and energy, then perhaps it was by nature an ancient white hole. Imagine everything space-time, even the constants of physics, erupting from a single invisible singularity. No one can peer inside that explosion. But its aftermath is evident everywhere. Galaxies expanding, the universe cooling. If true, we and the entire cosmos could be living in the last breath, blown out by a white hole from another universe. This opens bold ideas: multiverses, cyclic universes, or a universe flowing through endless rhythmic expansions and contractions with no true beginning or end. Evidence: are there any real traces of white holes? To date, no telescope has definitively recorded an event that confirms a white hole's existence. However, some phenomena have sparked speculation, most notably gamma-ray bursts, GRBs. These bursts are incredibly brief, lasting mere milliseconds, but release more energy than millions of suns combined in that short span. Some scientists once theorized that GRBs might be the final breath of a newborn white hole that collapses immediately. Yet this idea lacks strong support, as GRBs are more convincingly explained by known processes: neutron star collisions, supernovae, or extreme magnetic activity from magnetars. The information paradox: when white holes become a theoretical escape hatch. One of the greatest puzzles in modern physics is the black hole information paradox. According to Stephen Hawking, black holes slowly evaporate through quantum radiation and eventually vanish. But where does the information go? Quantum mechanics insists that information cannot be destroyed, it can only transform. This is where white holes emerge as a theoretical solution. Some models, like bounce cosmology, propose that when a black hole shrinks to a near quantum scale, it could bounce back as a white hole. Rather than disappearing, information would be expelled back into the universe. This theory is currently being tested in advanced quantum gravity models, especially in loop quantum gravity, where white holes are no longer distant mathematical oddities, but crucial keys to preserving information across cosmic evolution. If white holes are real, what would change? The discovery of white holes wouldn't just shake up theoretical physics, it would rewrite our very understanding of the cosmos. We would need to reconsider the beginning and end of the universe, the flow of time. Could it run backward? The finite or infinite nature of space-time, interstellar travel through wormhole gateways. More profoundly, white holes raise questions that step beyond science and into philosophy. How many child universes might be born from other white holes? Could humanity itself be the result of a massive matter outflow? We'll never fully understand. Might future civilizations create artificial white holes to escape the bounds of this universe? Why don't we have a definite answer? Yet white holes remain unconfirmed for several reasons. They may be incredibly rare and short-lived, making them hard to detect with telescopes. Any interaction with external matter could destabilize them, causing collapse into a black hole. No natural formation model is known, unlike black holes which arise from star collapse. Observed cosmic phenomena are already well explained by current astrophysical models, keeping white holes as a backup theory. The role of white holes in modern scientific thought. Despite the lack of direct evidence, white holes play a crucial role in theoretical physics. They represent the bold edge of scientific imagination, stretching our minds beyond what we currently understand. For this reason, white holes continue to be studied seriously at leading theoretical institutes, not because we are certain they exist, but because if they do, they may be the missing link in explaining the deeper structure and behavior of our universe. Conclusion: when a paradox becomes a doorway. In the pursuit of truth, science doesn't only chase the visible, it also follows paradoxes full of possibility. White holes, mysterious and unresolved, are a shining example. We may have never seen one, but theoretically they may be necessary. And perhaps in a future not far away, white holes could become the escape hatch through which humanity steps into a new chapter of understanding, a realm where time can reverse, where the cosmos is no longer a sealed bubble but a fluid network of pathways, twisted, tangled, interconnected, and infinite. We've just stepped through the strange door called the white hole, a concept that may seem paradoxical, yet could hold the key to the universe's deepest secrets. But the big questions still remain. If white holes are real, could we ever reach them or even harness their power? And do wormholes truly offer a passage to other universes? Or are they simply one-way trips with no return? In our next video, we'll dive into the fascinating world of wormholes, the cosmic tunnels of space and time to explore. Could humans actually travel through them? What dangers might be waiting on the other side? And how close is modern science to turning these legendary Einstein-Rosen bridges into reality? If you found this topic intriguing, don't forget to subscribe, hit the notification bell, and share this video to spread the wonder of science. See you soon as we journey through space-time in the next chapter.